Hello everyone and welcome back to exercise number 28 of the SolidWorks Basic Tutorial Series. In this video, we're going to be designing a column color. Now, in implementing this part, we're going to be using many of the SolidWorks features, such as the extrude boss base feature and extrude cut feature. Here we see the schematic drawing for exercise number 28, and all dimensions here are in inches, not in millimeters, but in inches, so please keep that in mind. We're dealing with the inch system here. Okay, so in modeling this component, I think we can do this in three main steps. Step number one is to work on creating this annular cylinder. So to do that, we sketch out a circular profile, or basically two concentric circles, by selecting the top plane. And then we're going to use the extrude boss base feature to create the thickness. And in this case, looking at the figure, the thickness or the height of this annular cylinder should be 1.25 inches, okay? And here we see that the radius of the larger circle is 1.25 inches, and the radius of the smaller circle, the inner circle, is 1 inch. So that is step one. Step one is to create the annular cylinder here. Step two involves working on this top lug. To do that, we select the top plane. Again, the top plane corresponds with the bottom of this component here, okay? And from the top plane, we're going to sketch out the outer profile of this lug right here, which basically approximates to this shape I've just drawn right now. And again, we're going to be using the circles tool, the line tool, the trim tool, the convert entities tool, but also the smart dimension tool, obviously. And again, here, please notice, again, forgot to mention that if we look at the component, we see that there's a symmetry for the component along the y-axis. So to save time and effort, it's sufficient or it's enough that we only draw one half of the component and then use the mirror tool to create the other half, right? So for example, in step number 2, which is to create the 2D profile right here, the outer profile of the top feature lug, we only draw one half. Let me do that again. We'll only draw one half and then use the mirror tool to create or to copy it to the other side, saving time, of course. Okay, so after we're done creating this outer profile, we use the extrude boss base tool to create a thickness, and in this case, it's going to be 0.5 inches. And that's step number 2. Step number 3, and that's the final step, is to work on the lugs, the right side lug, the left side lug, the back lug, and the opening here at the top. So again, utilizing the symmetry that's along the y-axis, we are going to model this right-sided lug in 2 stages, okay? Stage 1 is to sketch out the bottom profile of the lug, then use the extrude boss base tool to create the thickness, in this case is 0.25. Stage 2 is to create these, or actually, stage 2 of step 3 is to create the profile right here, the top profile of the right side lug, and then use the extrude boss base tool to create thickness. After that, we're going to use a mirror tool to basically mirror this model all the way to the other side right here, okay, to save time. And then what we're going to do is we're going to work on this backside lug by selecting the right plane. The right plane in this case is going to lie midway between the two components, dividing the component into half along its line of symmetry. And we're going to sketch out the side profile of this lug and then use the extrude boss base tool to create thickness. And in this case, since we're drawing on the right side plane, which lies midway, we're going to perform a mid-plane extrusion. And we have a thickness of 0.5 inches. Okay, and then finally, we're going to work on creating this opening here at the top. To do that, we select this space, this small strip here, and we're going to draw a rectangle. And it's sufficient that we only assign the width of this rectangle right here, because we're only concerned with the distance of this gap, which in this case is 0.63 inches, all right? After that, we're going to use the extrude cut tool to basically cut out this rectangular profile all the way to the surface right here. So as our end condition, we're going to use extrusion up to surface, okay, to save time. All right, so with that aside, let's get started with exercise number 28. Okay, so let's start by creating a new SolidWorks part. Now let's copy exercise number 28 into SolidWorks. And I need to remind you here that we're dealing with the inch system, right? And by default, we're set to millimeters. So To change that, go down here and select in the inch pounded second system. Okay, so as I said previously, we're going to model this with 3 main steps. And step number 1 involves creating this annular cylinder. So to do that, select top plane, sketch, select circle, and from the origin, draw 2 concentric circles, 1 and 2. Looking at the figure, we see that the radius of this larger circle should be 1.25, and the radius of this smaller circle should be 1 inch. So select Smart Dimension, and for the larger circle, a radius of 1.25 corresponds to a diameter of 2.5 inches. For the smaller circle, it should have a diameter of 2 inches. Now, here we see that the sketch is fully defined. Go to Features, Extrude Boss Base, and from the figure, we see that we should extrude this to a height of 1.25 inches. So assign a thickness of 1.25 inches. And then select OK. Next, we're going to work on this lug feature here at the top. So select top plane, sketch, select circle, and starting from the origin here, we move vertically and draw 2 concentric circles, 1 and 2. So basically, these 2 points, the center of this concentric circle and the origin is directly overhead, so they're vertically aligned. Now select Smart Dimension again, and from the figure we see that the radius of the larger circle should be 0.5 inches, and the radius of the smaller circle, which is the hole, should correspond to 0.25 inches. So the diameter here should be 0.5 inches, since we have a radius of 0.25. And the diameter of this larger circle should be exactly 1 inch. Okay. Again, distance between the center of this larger cylinder and the center of these circles from the figure should be 2.5 inches. So the center, or the distance between this origin and this point, should be 2.5 inches. Now we need to close off the sketch of this top lug. So select line, and from this circle, draw a line. And you can pretty much end the line in any place within the sketch. Let's say this point right here. Now select this surface and use the Convert Entities tool. So basically what happens here is that we've created an independent sketch for the outer perimeter of this cylinder, right? Now select Entities and delete this extra line. And from the figure, we see that the distance between the 2 extremities of this top lug feature is 1.5, and that there is a symmetry for the component along the y-axis. So the distance between these 2 points should be 1.5 divided by 2. So select Smart Dimension, and the distance between this center and this point is 1.5 divided by 2. Right? And let's go ahead and assign the relation between this line and this circle as tangent. Okay, so after we've done that, we've set the relation tangent, we notice that these 2 points, the origin and the center of these 2 concentric circles, are no longer vertically aligned. To fix that, basically or simply select this center, and on your keyboard, press the Control key, and then go ahead and select the origin. And for the relations, set the relation between these 2 points as vertical. All right, now these 2 points are vertically aligned over each other. Then select OK. Now, like I said before, there's a symmetry for this component along the y-axis. So what do? We simply draw a center line starting from this point right here, a vertical center line. We're going to select the Mirror Entities tool, and it's going to ask you for the entities to mirror, and simply select this line. Mirror about the vertical center line we just created, and then select OK. Select Trim Entities and delete this extra curve and this line right here. All right. Now we have the 2D sketch for the base of this top lug. So then go to Features, Extrude Boss Base, and from the figure, this sketch we should extrude it to a thickness of 0.5 inches. So enter a thickness of 0.5 inches and then select OK. Now we're going to work on creating these lug features to the side. And like I said previously, we're going to do this in two main stages. Stage one is to sketch the base profile of the lug, and then use the extrude boss base to complete the thickness. In this case, is 0.25. And stage two involves creating or drawing this sketch on this top surface, and then using the extrude boss base tool as well to extrude. So this is a two-stage lug extrusion process. Anyway, so to do that, select top plane, sketch, select circle, and from the origin here, just move horizontally and then draw a circle. So basically now we have a circle that is collinear with respect to the origin. And what do we do to fix that so it doesn't move anymore? Select this point and this origin and set the relation as horizontal. Okay. Now select the Smart Dimension tool, and from the figure we see that the radius of the circle should be 0.38. So a diameter of 0.38 times 2. And the distance between the origin and the center of this circle should be 3.25 divided by 2. Again, here we see that the dimension is basically the distance between the centers of these two symmetrical lugs. And since the center of this cylinder lies midway between these two extremities, so basically we can assign a distance between this center and this center as 3.25 divided by 2, right? And select OK. Now we're going to close off this bottom sketch, using the line tool. So select line, and then from the circle here, draw a line all the way to the other side. Again, select the surface and convert entities using the trim tool, delete the extra line. And from the figure, we see that the distance between the two extremities of this side lug is 1.25. And since we have symmetry, the distance should be between this point and this point should be 1.25 divided by 2. Okay. Now we need to mirror this line to the other side. So simply select center line and draw a horizontal line. Sorry, let's do that again. Center line. And from this point, draw a horizontal line. Now select mirror entities. And here it's going to ask you for the entities to mirror. Simply select this line. And it's going to ask you to say, okay, I want to mirror this line by about what axis? So select this horizontal axis and then select OK. All right. Go to trim entities and then delete any extra lines, leaving behind the outer profile of this base lug right here. All right. Select OK. Then go to features and extrude boss base. And from the figure here, we're going to extrude this profile to a thickness of 0.25 inches. So go ahead and assign a thickness of 0.25 inches. And select OK. So stage 1 completed. Now stage 2 involves drawing the sketch of this top feature, or this top sketch. So select this face, sketch, select circle, and simply hover over this curved edge, and SolidWorks pretty much still recognizes this curved line as a independent circle, and this is the origin of the circle. So simply draw a circle starting from this point all the way to the other side. Now use the line tool, and from this point, close off the figure. Select the surface, convert entities, select trim, and delete any extra lines. Leaving behind the final 2D sketch, right? Select OK, go to Features, Extrude Boss Base. Go ahead and select this sketch. And here we see that we should extrude this to a height of 0.25. Why? Because the overall height of this slug is 0.5. and half of it is 0.25, so the other half is 0.25, right? By default, it's always set to 0.25, and then select OK. Finally, we're going to create this hole here. So select this surface, sketch, use circle, and again, from this point, draw a circle. And the circle should have a radius of 0.19 inches. So using the Smart Dimension tool, assign a diameter of 0.19 times 2. Go to Features, Extrude Cut, drag this arrow all the way to the other side to, again, we have a hole that's penetrates all the way through the component, and then select OK. Now we need to mirror this all the way to the other side, and we're going to utilize the symmetry of the component along the y-axis. Instead of wasting time and redrawing everything, we're going to select the Mirror tool, and here's where it's going to ask you for the face or plane you want to mirror along, and simply select the right plane. Okay, and now here it's going to ask you for the features to mirror. Simply select as many faces as possible for the lug you just created. And here you can see in yellow a preview of what the mirror tool is going to create, and then select OK. Right? Finally, we're going to create this lug here at the back. So select right plane, sketch, and looking at the figure, we can approximate or create this 2D sketch by drawing two concentric circles at first. The larger circle corresponds with the fillet radius, and the smaller circle corresponds with the hole here at the side. And then using the line tool, we're going to close off the figure according to the geometry shown. Okay, so now select circle and just draw two concentric circles at any point, 1 and 2. Select Smart Dimension, and then let's go ahead and assign diameters for these circles. We have this larger circle here, should have a radius of 0.5, so automatically should have a diameter of 1 inch. For the smaller circle, which is the hole, it says here that it should have a radius of 0.25. So this should be 0.25 times 2, which is 0.5. Okay. Now here it says the distance between this bottom edge or this bottom surface of the components with respect to the center of this circle should be 0.5 as well. So the distance between this edge and this point should be 0.5. Right? And there's an important note here. It says here, distance of 1.75 inches from part center. The part center corresponds to the center of this larger annular base cylinder, okay? Which in our case is the origin of our 3D component. So the distance, the horizontal distance between this point and this origin is 1.75 inches. Okay, now use the line tool. I'm going to close off the sketch as follows, all the way to this edge right here. Again, we're just the 2D profile of the component as to the best of our ability. Now use the Trim Entities tool and delete any extra curves, leaving behind the final 2D sketch of the side view for this this lug here at the back. Now select OK, go to Features, Extrude Boss Base, and we're going to set the end condition as mid-plane. So we're going to basically extrude this in both directions. And from the figure, we see that we should extrude it to a thickness of 0.5 inches. So go ahead and assign a thickness of 0.5. And then select OK. All right. But there's something important that we need to notice here. There's a gap. There's a small gap between this extrusion that we just created and this curved surface. The reason is that the Extrude Boss Base tool is a linear extrusion tool. So we have a 2D sketch and we extruded it in a linear pattern along a curved surface. So naturally, it's not going to close up properly. There's going to be a gap here at the top. If we look at the top view here, and zoom in, you see there's a gap. So how do we close off this gap? The easiest way to do that is simply select this back face, press Sketch, use the Convert Entities tool, which again, what it does basically is it converts the outer perimeter of the surface or the surface you've selected to an independent sketch, okay? And go to Features, Extrude Boss Base, and we're going to set the end condition here as up to surface. So now SolidWorks is saying, okay, Glenn, you want to extrude this 2D sketch, but up to what surface? And we're going to say up to this curved surface right here. And that, if we look at the preview here, that is going to close off the two solids together. And then select OK. Now we don't have any gap between the two components. Look at the top view again. The gap is no longer existent. It's a curved extrusion now. Okay, and this corresponds with what we have here in the diagram. Okay, so now finally we need to work on creating this opening here. So select this top face, sketch, select center rectangle, and starting from this point right here, draw a rectangle. Using the Smart Dimension tool, we assign a distance for this edge as 0.63 inches. And then the distance of this edge, or the length of this edge, basically corresponds to the distance of this gap, right? And you really don't need to assign a length for this edge, because we're only concerned with the horizontal distance right here, the gap of distance. So then go to Features, Extrude Cut, set the end condition to as up to surface, and we're going to select this surface right here. And then select OK. And that creates the opening that corresponds to a 0.63 inch opening. Now delete this image, set the background to plain white. Let's go ahead and assign a material, edit material. Again, you can select any material, but for this purpose, we'll select ASI 304 steel, apply, close. All right, so that concludes exercise number 28. If you've enjoyed this video, please don't forget to like, subscribe. If you have any comments, I'd love to hear them down below. Until we meet again, I'll see you all in exercise number 29. Have a nice one. Bye-bye.